Hello everybody. Well, as promised, I will do the experiments that we didn't have time to finish this week when we were in lab. So right now, before I even get started, I will test all my reagents, do my controls, and make sure that I have expected results with my controls so that I don't run my experiments, have no results or weird results, and waste a lot of time if it's the chemical's fault. So first thing I want to do is have a look at starch. Starch I have in my little container over here, so I will put in a spot well 100 microliters of starch, and it is just clear when it's on its own. In another well, I will put 100 microliters of iodine, potassium iodine, or IKI, and we can see that when iodine is on its own, it is an orangey color, amber, yellow, brown, whatever color you want to call it, but one thing for sure, it's not blue. Now we're going to try to put starch together with iodine and see what happens when they are in contact. So we have our starch, of course clear as it was in the first well, and our iodine. And as you can see, it turns really dark blue. We could almost call it black. So here we have a positive reaction between starch and iodine. Iodine is an indicator for starch, so when it changes color, we can tell there's starch. Now, when we run our experiments, we'll see how salivary amylase digests starch, and we will use iodine to assess whether there's starch or not left in a reaction. So we need to know that the breakdown of starch by salivary amylase, which is maltose, does not react with iodine, because if maltose also turns blue with iodine, we won't know when we don't have starch anymore. So the next control I will do over here is I will put a drop of maltose. Maltose is the product of starch digestion by amylase, which is the enzyme we're going to use. And when I mix it with 100 microliters of iodine, we can tell that it's not blue. It's the same color as iodine on its own, a little lighter colored because of course it's diluted, that iodine is diluted with a clear liquid, but it's definitely not blue. So we can tell when there's no more starch. Now, one more control we have to do, and it's an important one, is to make sure that only starch turns blue when we mix it with iodine. If our pH solutions or our enzymes turn blue with the contact of amylase, whether there's starch present or not, we won't be able to tell, once again, if there's starch or not present, if other molecules make iodine turn blue. So for that, I could put one drop of each reagent in a separate well and add a drop of iodine to each of them. But I'm just going to mix them all together and add a drop of iodine. And if nothing is blue when they're all together, mixed with iodine, then I know that nothing makes it turn blue. If it did turn blue, then I would have to test the reagents one at a time to see which one makes it turn blue. So I'm going to start with the pH 4. I'll put a drop of pH 4 in a well. And then I'll put a drop of pH 7 in a well, the same well. And then a drop of pH 10 over here. And a drop of maltose. Now, I will not put starch in there because if I did put starch, it would be blue, and that would not give me any information that I don't know already. We've already tested the starch, and the starch does indeed react with iodine. What I do have to put in there is our amylase solution that I have over here. Let me grab some clean tips for that. So we don't want to contaminate our amylase with any of the reagents in case their presence has an influence on how amylase reacts. So I will change the tips, use a clean tip in my own salivary amylase. I have collected some of my saliva, and I will put it in the first well, or not the first, but the well with all of those reagents. There we go. And I will also test the commercial amylase that I purchased for this lab with a clean tip also. Got it over here in the well. So when all these reagents are together, it's not blue. And now let's try putting a drop of iodine, see what happens. And it's definitely not blue again. So we have confirmation that the only reagent we use that reacts with iodine and becomes dark blue is starch. Now the last thing we need to test is that our amylase that we're working with, the one from my saliva and the one that I purchased, both break down or digest starch. If the enzyme doesn't work, no point running a reaction, an experiment to see which conditions are best or worst for each amylase. So for that, I will put a drop of starch and a drop of, there we go, I will use the same trick I had before for starch, a drop of starch and a drop of amylase and clean wells, and I will let it digest for a few seconds and then add iodine to see if the reaction happened. So let's start with starch. I will put starch over here. I will over there. I will do starch in 4 wells. And the reason I will do it in 4 wells, I will have 2 wells for each type of amylase. And that way, when I add iodine, if it's not completely digested, I can test it again in a few seconds later in the other well. So now that I have the starch, I need to add the amylase. So 1 drop of amylase in each well. I will keep the salivary amylase in these wells over here on your left. So here's salivary amylase here, salivary amylase over there, and the commercial amylase, 1 drop over here, 1 drop over there. Now just to make sure that the amylase is in contact with the starch, they need to be in contact to digest, I will stir with a toothpick, and I will make sure I use different toothpicks in the wells that contain different type of amylase. All right, well now I'm ready to start, see if the starch is all digested. So I will try in 1 well. Oh, well, it's certainly not black like it used to be. It appears that there's still a little bit of starch left. It's not yellow. We can leave that one last a little longer. And this one here, which is a similar color. So we can wait a few more seconds and test the other well that is still in the process of digestion. But we can tell already that that amylase does indeed break down starch, because when we put starch and iodine without any amylase, it turned really, really dark right away. And here, it is not as dark. It's brown. It's not yellow yet, but it's certainly not black. All right, so let's try another drop. One over here. Oh, I didn't put the right. Silly me. There we go. Let's do this one here. There we go. With the iodine, it does work. And with, there we go. So these things here are, the one on this side here has been digested a little faster. Of course, I set it up first. This one is a little bit slower, but it's still in the process of digestion. So I would say that our controls gave expected results. It appears that our chemicals work the way they should, and we can be confident that we can run the experiment and trust the results we have in different conditions of temperature and pH.